The aluminium ladder is the height of convenience. Lightweight and sturdy, it makes any ascent easier. Wooden ladders used to be standard, but were extremely heavy, difficult to position, and would eventually rot. The use of aluminium took things to a whole new level. For a ladder to really stand up, the aluminium needs to be strengthened with these ingredients: silicon, magnesium, manganese, and copper. It all goes into a furnace. A crane transports a hopper full of aluminium over to the furnace. The hopper opens at the bottom to unload. A door is opened at the front of the furnace. The operator wears a face shield to protect him from the blistering 700 degrees Celsius heat. He adds the other ingredients, and the heat turns it all into a liquid mass. The liquid flows out of the furnace into troughs. It seeps through holes in the troughs to moulds in the ground. The liquid cools and hardens in the moulds. This makes log shapes that are almost 7 meters in length. A hydraulic lift extracts them from the moulds and slowly takes them to the next station. You wouldn't want to rush this job. Each log weighs 500 kilograms, and dropping one could do serious damage. A saw cuts them into pellets. The size depends on the type of ladder being made. A mechanical lift delivers a heated pellet to an extruder, and a ram pushes it into the opening. They move the die plate into position. The ram forces the hot pellet through holes in the die plate. This makes a rail shape 40 meters long. A puller drags the rail onto a table and leaves it to cool and harden. Then, a circular saw slices it into manageable 6-meter lengths. Each end of the rail is fed to jaw systems, which pull it to make it completely straight. The straightened rails now move on to the next station, where plastic feet are riveted onto the ends to keep the ladder from slipping. Safety information is stuck onto the rails, and the ladder is assembled, one step at a time. Each step is fitted in the rims of the ladder rails, then riveted in place. This will be the front of a light-duty stepladder. A diagonal brace is installed, and the ladder is turned over so that the steps can be riveted from the other side. A sturdy blue plastic top is fixed onto the front and back pieces, joining the two. The spreader is also installed and secured with rivets. And now, this stepladder is ready to provide a little elevation. For a lot of elevation, extension ladders are produced. Cylindrical rungs are used for greater strength. Each rung is fed to a machine which tapers the ends. Another machine presses aluminium ferrules onto each end. This allows the rungs to fit snugly into slots in the extension ladder side rails. Hydraulic arms reach from above and below to press fit the rungs into the side rails. Finally, workers rivet rubber pads onto the ends of the rails. This provides a firm footing for the ladder. These ladders are now complete, and if you're on your way up in the world, they'll come in handy.